everyone. Sunday, March 14th again, and I was so pleased with that last video, I thought I'd do another. It starts off with me losing my train of thought, but it will come back to me because it was so powerful that I was like, I gotta shoot myself a new video here to continue this thought. Oh yeah, I got it. So the way it goes is there's a certain shaming into using functions. There's a certain shaming into using object-oriented programming style. There are certain tasks, common, purposes for software that fit those respective styles. If you're releasing a package into PyPy, you often are going to want it to use object-oriented techniques because people are, quote, using your stuff. And the concept of instantiating an instance of your stuff that has .this and .that all inside of it is understandable. It's when you're a consumer of somebody's object-oriented package, it seems to be rather easy to grok. So the request HTTP package for humans is probably the best example in the Python community because everyone loves it and knows it and uses it. Well, not everyone, but on average, it's the API that's been embraced for doing HTTP communication. The day comes when you have to change your headers, okay? Alter your user agent, and you're like, wait, using the URL lib123, you have to do what? And is there a better way is always answered by, oh yeah, here, use request. It's API for it's HTTP for humans, a good API, a well-designed API. And, had extended the very notion of what it was to be Pythonic. So object-oriented got into a lot of people's brains and minds subconsciously through that. And it also got into our brains and minds subconsciously because even though you don't think about it as such, whenever you import a package, you're using object-oriented design because that handle that package has, now that it's in memory in your local execution space, is an instance of a class. It's an instance of that package that you just imported. And it has any values that have been set internal to it become properties of that class, so you can access their values. Any functions that are inside of those become methods of that class. You can call those functions. Without parentheses is an instance of the function, so you can rename it and move it around. With the parentheses is invoking its use, so you can use it. And if there's an API discovery system and you got good named keywords, you could figure out the API, create auto documentation, and then when you know the API, you can shape one of your named tuples to fit that API, considering it's not like a dictionary that needs to be passed. If an API calls for lists and dictionaries to be passed, you can't necessarily do my favorite trick, but one of the things I look forward to teaching in these videos is a splatty style of communication. So things have to communicate to things. No matter what it is, there's a part of your program that needs to communicate to another part. There's a service that needs to be talked to or something. So I hope to use these in 0MQ. I'm hoping that name tuples are the kind of thing you can pass around between ports, listening ports of these different things that go to listen for their communication on these ports. It's like having a little web ecosystem without the overhead of a message queue, right? So Jupyter is doing some magic underneath that makes it so friggin' responsive, having that server in the background and all this Python execution REPL code happening in the browser. Well, that magic of that communication is 0MQ, and I keep bringing it up. It's the latest thing that I'm infatuated with, but haven't really taken the plunge yet. So that's in the future, as soon as a project calls for it. The things that are really happening now, every project calls for making HTTP calls and getting something back you want to store fast without parsing it. So, name-value pairs, where the value is a blob that you can just drop in, and you can back-end it with SQLite, which is included with the Python standard library. So all you need is the SQLite dict, which allows you to use the Python dictionary API with SQLite as the back end for your blobs, for your quick rapid fire hitting of APIs, maybe using a little concurrency because it supports multi-threadedness in the database rights these days. It's pretty important now to look for that support in your SQLite tools, because the temptation of concurrency will possess you, and you'll be able to make 50 web requests in the time it took you to make one. And you're going to need to be able to write all that API response somewhere, so you're going to need it to be multi-threaded the same way concurrency is, and you're going to want to do it fast. So use the highly optimized C compiled. It's a component of Python, the way NumPy is a component after you install it, that is optimized in high performance C code. So the SQL part of Python is really a neat little trick, and you hear it talked about more and more. It's everywhere. It's and it's not as universally hated now as like regular expressions have become. It's a lot like the Perl implementation of regular expressions is now in everything. It's a generic regex engine. So there's a generic SQL engine. It's SQLite, and it's fun to use. And so there's always communication between parts in your system, and generally things have to map cleanly. You don't want parsing to occur. Things just drop into their rows and columns, such as it were. You're adding to the list, giving a known list format. So if you have that kind of environment, using name tuples as those communication bubbles that get shot between application components, system components, then use name tuples because you're going to like the advantage they give. And I never thought I'd be teaching how to use a factory class to create new instances, subclasses. It's the stuff I just never do. I'm not an OO person. However, this API is very interesting. When you import named tuple, that is the factory class, period. So something is going to be equal to that, and you're essentially going to be renaming it as something else. So named tuple, open parenthesis, around something, close parenthesis, it becomes an instance of a named tuple. So when I showed this in Jupyter, which is probably coming up real soon, I am not going to set anything equal to that yet, because giving it a handle, making it anything other than a named tuple just statement and not an assignment. You can have a statement without an assignment if you take the equals out. So to have a named tuple statement and to just run that in Jupyter will provide a lot of the key insight you're going to want in understanding and wrapping your mind around these things, and appreciate how broadly and widely they can be used. Because when you create a new instance of a named tuple class, it is a record in a database. Name equals, extension equals, whatever. Title equals. It is a tuple. The data type, it is a tuple, but each one of those positions in the not list, because it's a tuple and not a list, is, say it has 3 positions. Each one of those positions now can have a label. First name, last name, extension. It's just a quick lookup thing from the old-fashioned days when we were sitting in the same office and we dialed an extension to talk to people, when we were in offices. Boy, those were the days. Those were the days. I digress. 3 positions, first name, last name, extension. That is a tuple. But if it were just a tuple, you could not identify those positions as such. It was blind position dependency. Your code needed to know to use what was in position 1 for first name, what was in position 2 as last name, and what was in position 3 as extension. You couldn't look at the tuple and go, oh, well, this is first name, this is last. You probably could figure it out from the data, but wouldn't it be nice if there were a label that's the primary function of a named tuple? But now, once you create one by using name tuple, open parenthesis, that creates that's the factory maker, so you don't use it directly. You have to create your own data type first. You have to create an employee data type, okay? So create an employee data type would look like, and forget the assignment, this is the statement, the word name tuple, open parenthesis, quote, the word employee, generally with an uppercase E, lowercase rest of the world, close quote, because, that's a string. The name of your data type is employee. You've created the name of your data type. The name tuple, open parenthesis, name of data type, in quotes. Comma, and then, here's where it gets really interesting. It's a list, and you can use a list, but if you're too lazy to use a list, or you use these things so much, you don't want to create a list, square bracket, especially if it's strings. If you're using strings, you got to have all these quotes. Wouldn't it be nice if you just had 2 quotes, because everything's a field name, so there's no spaces in it. You gotta use field name logic for your property names. So your name of your data type, employee, gets followed by comma, quote, first name, space, last name, space, extension, close quote, close parenthesis. That's a name tuple. Now what you can do with that is you can say something equals that. Now you use your assignment. And so when you have an employee named tuple, you can access its first name by doing instance of class, which will be like, say, employee with a lowercase, right? You're in object-oriented land, so what you're going to find is that, the first, meta class, the template from which you make instances of classes, they use an uppercase, or it's in camel case, or because it's in Python, it's in camel snake case, where each word has an initial uppercase. You then go to lowercase, and if it needs more than one word, you put an underscore between them, which is snake case. Python is typically snake case for variable names over, say, camel case from JavaScript and many other languages. So you do see a lot of camel case mixed into Python, and the PEPs address this and say, except where previous code has a tradition or whatever. So in object-oriented in Python, it's very particular. You're using camel snake case for master or meta classes, top level stuff that you instantiate from. And then when you instantiate an instance of it, so it's employee uppercase for that meta class, and when you instantiate a single employee, it's lowercase e for employee. And you can use the same name because there's a certain purity. Why litter it up with arbitrary things? This is where you see a lot of people using myvar, my variable, my int. You also see a lot of underscore at the beginning in Python, because underscore is a valid variable name, reference name, character, and it can be used at the beginning where you can't use numbers. So it's very easy to see underscore list as an instance of a list, right? So in the same spirit, we do lowercase employee equals what we now have is uppercase employee, or camel case, or snake, or camel snake case employee. You don't see the snake, but an employee. Open parenthesis. Now you don't need to rename it because the name has been used in creating this instance. Now you just go to the properties, attributes, whatever you want to call them, and you don't need to use the labels when you create an instance of it. You can use the positions and just say, you know, quote, you know, Fred, comma, quote, Fredberger, Fredberger, and comma, extension, close parenthesis, instance of your employee class. And to access Fredberger, to get to the Fred part, it would be employee.firstname. Forget square brackets and forget indexes. You know, if this were a dictionary, you would have to use the square bracket notation. That is so popular in Python, and less so in other languages where the dot notation is more frequently used. But these are Python conventions, and they're occasionally violated by an API that has something really particular in mind. And the named tuple, and you can go read the PEP for it. I'm sure this is all covered, the thought process behind this stuff. But the people who thought you should have these really lightweight, object-oriented, you know, factory creatable data types, because it's a data type you're making, also felt you should be able to use dot notation to access the values of an instance. So it becomes really nice because, you know, employee.name, right? It's very natural. It's a very, very natural API to use. And once you get the hang of it, the import is the hardest thing about it. Now, the understanding that the repetition of creating the factory, using the factory to create a meta class, and then using the meta class to create instances of the meta class. To do that without any of these tongue twister keywords ruining the actual easiness of understanding what's going on. It's a case where the spoken English language really gets in the way, where the lingo surrounded object-oriented notation is more of it. It's not its friend. And to actually just use it a few times, to use it without assignment a few times, to use it as a statement a few times, to go, oh, that is a named tuple. Oh, you got to set something equal. Oh, that's the assignment. Oh, but that still doesn't give you. Oh, that's the stamping out instances from a meta class of a data type. It makes more sense using it and doing it than it does talking about it, especially with the traditional terms that have come to represent these things in modern computing. OO can be your friend. It has not been mine over the years. However, Guido tricked me into using it by making use of the importability of .py files. Now I'm using OO. And since I might as well get a few other advantages out of it. Specifically, really small bundles of attributes tied to objects with little bundles of key value pairs inside of it, but isn't really a dictionary because it's not, it can't go on forever. It's a few numbers of fixed positions. Position 1 is named this, position 2 is named that, position 3 is named that, and then these become these little communication bubbles that self-document and zip between systems. Maybe not the 100% most efficient because the labels take up some space. It's not, quote, a normalized kind of communication. There's a lot of redundancy in it because the labels are always resent, but I like that. You're not always looking for that kind of efficiency of getting it down to the bits and the bytes, or else we'd all be using assemblers still. We like our high-level languages, and we concede here and there to verbosity, and name tuples is one of the places you do it. I like to do it because things get really, really clear in one's mind what you're dealing with. And when you use it to send it to a function, and you have to map those locations inside the name tuple to locations in the function's expected inputs, if they line up, if you've got the right values in the right order, you just use that object name in the function call between the parentheses, and you insert a single asterisk if you want it to be position dependent unpackaged into location, and you put it with 2 parentheses if you want it to unpack as a dictionary and provide key value pairs to an API input that's expecting key value pairs. I believe you can splat dictionaries in that same way, but you can certainly splat name tuples because I've been doing it for a while using this technique, and can't wait to show it to you. It truly is the unlikely next thing up in a universal project framework for my data engineering type career that used to be SEO, search engine optimization, but everything's a script, everything's starts out in Jupyter Labs, and everything gets promoted to true automation, etc., parameterized as a command line, and you get the idea. Thanks for joining me. Hope to see you again soon, and don't forget to subscribe.